Hey everybody, David with Sprocket and Rotor Coffee. Just wanted to take some time and walk everybody through my ventilation system for my Aillio Bullet Roaster. I stole this from a gentleman who was selling his bullet on Facebook, and he had some images, and I pieced together how he set up his exhaust system from those images. I don't know who that person is. Thank you to whoever you are, but I wanted to take the rest of you piece by piece and explain what is involved in it and how I went about it. Functionally, the goal of venting your roaster is to pull heat from the exhaust on the roast drum here and heat from the cooling tray here. The exhaust from the drum exits the roaster into the 6" to 4" reducer, and then I've got a semi-rigid flexible tubing down to straight metal pipe. Those are 2 foot each, down into an ABS plastic 4" 3-way T here. So both heat sources are sucked in there. I've cut a hole in the table, venting. The T sticks down through the hole and then runs my inline fan. The bean cooling tray provided by Aillio has a built-in fan in order to suck air down through the beans and exhaust out the back of the cooling tray. But if you want to control where that heat goes, it's helpful to hook it up to some sort of exhaust ducting. I've used flexible exhaust ducting here that you would use for a dryer. I bought the heavy duty. I'll connect links for everything I purchased, will be in the description. But in order to connect that 4" ducting to the tray, you're going to need an adapter. Aillio provides the 3D printing file online for free for this adapter, as well as a couple of other parts. I went ahead and purchased mine offline from someone that had 3D printed it. If you know someone with a printer, you have a printer yourself, you can save a little bit of money there. The great thing about this setup is it requires no scaffolding. By drilling a 4" hole directly into my table using a 4" hole saw drill bit and sliding the 3-way plastic T directly down into that, which fits perfectly, I was able to connect the round metal duct pipe going upwards to the semi-rigid flexible aluminum duct, which arches over to catch the exhaust that comes right out of the bullet. You can see here where the ducting comes directly through the table. That's the bottom of the 3-way T, and curves over towards my inline fan here. For this setup, I originally had a 100 cubic feet per minute inline fan, and that was not nearly enough. This one is 195 cubic feet per minute, and I absolutely recommend something of that nature. For easy access, I mounted my fan speed controller for my inline duct fan on the side of my table. During roasting, I'll keep it at about half power. As you turn it up too much, it can have a tendency to suck a little too much air out of the roaster and may drop your heat as you're roasting, and you want to be careful of that. But very easy access in this location. Here's a good overview of the entire system. The exhaust gases come down through the metal ducting above the table into the T here, again curving underneath to the inline fan here, and then coming all the way down and up and out of my aluminum window dryer vent kit installed in the window there. I owe a very large thanks to my silent partner in Sprocket and Rotor who helped me craft the framing for the window venting unit and the dual fans. As you can see here and here, we've installed handles so you can grab the whole unit, pop the window up a little bit, and pull the entire unit out so that you don't have to have that left in your window when you're not using the system. That way you can still close and lock your window and help trap heat or keep out the heat depending on the season. Thanks to the magnetic coupling for the dryer vent tubing, it can be removed like so, and the draft cover on the twin fan like so. Again, I created redundancies at every single connection save one by using both extreme temp HVAC foil duct tape and galvanized steel worm gear clamps. The entire system, I needed 10 of the worm gear clamps. I will say the extreme temp HVAC foil duct tape is probably not necessary. I can't remember the number, it's 240 to 280, somewhere like that. But multi-purpose foil tape will do the same thing, which can handle up to 200 degrees. I've used a laser temp gun that you see here to measure temp operating temperatures, and the T seems to hold the most heat, which makes the most sense, but it only reaches somewhere in the range of 100 degrees Fahrenheit. So thanks for watching. I hope this was helpful. If you have any questions, drop a comment and I'll answer them for you. I will leave links for every single thing I purchased in the comments below. And again, thanks for watching.